So this is my presentation on sports biomechanics and biomechanic principles by Max Wilkins. So here's a little contents, and we start off with the anatomical principles. We read linear and angular kinematics, and then linear kinetics and angular kinetics. So what are anatomical principles of muscle contraction? So there's three different types. There's isometric, where the muscle lengthens and do not change during contraction. Isokinetic, which is a contraction where muscle shortens and lengthens at a constant linear speed. And finally, isotonic, where the muscle length changes during contraction. So the first one is isometric. So again, that is the muscle where the muscle is a constant length. So this means the muscle has no applicable change in its length during the exercise. So a sporting example would be something like gripping a tennis racket or a badminton racket. If you're doing like a tug of war or skiing, this is because their muscles don't change in length, but they're applying force, obviously, to hold the handle or to pull the rope. If we move on to the next one, which is isokinetic. This is where the muscle shortens or lengthens at a consistent linear speed. This means that the muscles can shorten and lengthen. However, this will be produced will be at a constant speed. It's harder to find sporting examples of this type, but one would be cycling on a bike in the gym. As you set the resistance on the bike so it doesn't change, so it's a constant resistance to the obviously the movement of adduction, which is a movement that is made towards the middle of the body. Obviously, this makes the strokes at a constant speed. So another one would be like breaststroke in swimming. And finally, isotonic, which is where the muscle contracts against a constant load. So this is like two examples would be a bicep curl and a squat. Because obviously there's two phases, so the up phase and the down phase. So obviously in the up phase, one muscle contracts essentially, which means it lengthens, and then obviously in the other phase it will contract concentrically and shorten. So if you're looking at a squat, and they use multiple joints and muscles, so it's done most eccentrically as the muscles lengthen to provide a braking mechanism. This slows the rate of movement and protects the body against injuries. So if we look at mechanics of muscle contraction, if we look at a bicep curl, so you have agonists, which is the muscle that contracts in order to move a joint, and obviously you have antagonists, which is the relaxing muscle that works against the agonist. So as you can see in the first picture, which is the down phase of a bicep curl, the agonist here is the tricep, and the antagonist would be the bicep, because the bicep lengthens, and the which is the agonist, and the antagonist, it lengthens because it's the antagonist, but the agonist contracts. But on the up phase, it's the reverse. So the agonist becomes the bicep, and the antagonist becomes the tricep. So a synergist is a muscle that they are muscles that enable agonists to operate more effectively. They work with agonists to control and direct movement by modifying or altering the direction of pull of the best position. So when you're performing the bicep curl, there's not only the bicep and the tricep, but there's obviously other different muscles around it that obviously help these muscles and the joints with the movement you're making. These are called the synergists. And there's also fixators. These are muscles that stop any unwanted movement by fixing or stabilizing the joint or the joints involved. Fixator muscles obviously stabilize the origin so the agonist can achieve the maximum effective contraction. If we look at reciprocal inhibition as well, in relation to this is the process of the muscles on one side of a joint relaxing to accommodate contraction on the other side. So if you look at the bicep curl again, it'd either be the tricep and the bicep working with each other. This is controlled by two opposite sets of muscles, so the bicep and the tricep, which are opposite muscles, and extenders and flexors, which must work in sync basically to create the smooth movement. Now on to kinematics. This is the branch of mechanics considered with the motion of objects without reference to the forces which cause the motion. There are two different types, which are linear kinematics and angular kinematics, which I will go through in a second. So we'll start with vector and scalar quantity. So a vector quantity takes into consider both size and direction. So things like velocity, acceleration, momentum, force, lift, drag, thrust, and weight. And a scalar quantity only has size, so length, speed, volume. So if you're looking at how fast Usain Bolt ran the 100 meters, in it'd be a scalar quantity because it only has one figure of how fast his optimum speed was. How to work it out. So if you're working out a vector quantity, you've got displacement at the top, velocity times time. So if I was looking for the displacement, I would do velocity times time. If I was looking for the time, I would do displacement divided by velocity, and so on. And for scalar quantities, it's distance equals speed times time. Again, if I want to work out the time, I do distance divided by speed, so on and so forth. If we look at linear kinematics first, this is the movement in which parts of a system move in the same direction, same speed or acceleration. There are two different types, rectilinear and curvilinear. So rectilinear is in a straight line. So this would be like in the 100 meters. If Usain Bolt was running in the 100 meters, his start position and his finish position are in a straight line. However, curvilinear is if he was running, say, the 200 meters. So his start and finish position are not in a straight line, they go around a curve, obviously because of the track. And then going, if you look at the types to the angular one, which is next. So angular kinematics is pretty similar. So instead of having, so if certainly you scale and vector quantities, it'd be like angular acceleration, angular speed, things like that. So these are measured in radians or rads. So 1 rad is 57.3 degrees. And if you take the 360 degrees in a circle, this equates to 6.28 rads. So when you're trying to convert your degrees into rads, you have to divide pi by 180 and then times it by the number of degrees. So if you look at the one I've done underneath, so if we had 200 degrees, so you do pi divided by 180, which is 0.2, and then you do 0.2 times the 200 degrees, because that's the degrees we're working with. It gives us 3.49. And then you just divide it by, how long it took in seconds. So say it took 6.2 seconds. I divided my 3.49 by 6.2, which gives us 0.52 rads to the minus 1 second. So moving on to kinetics, this is the branch of mechanics including both dynamics and kinematics concerned with the studies of bodies and motion. So this considers force as well as movement, because kinematics doesn't consider force, it only considers movement. So in this one, you'd be considering things such as gravity, friction, like forces from the ground, air resistance, stuff like that. If you're looking at Newton's 3 laws of motion, so there's 3 different ones. The first one is a body continues at a state of rest or uniform velocity unless acted on by an internal force. So if we look at this in a sporting example, so a football at the start of a game would stay on the centre circle until it's kicked, and a football would not. And if the football was in the air, so someone had kicked it in the air, it would not fall to the ground without the help of gravity. If you look at Newton's second law, so this is another triangle, so it'd be force equals mass times acceleration. So if you look at the baseballer, so if we're trying to work out the force that it's exerting, we know what the acceleration is, and we times that by the mass of obviously the bat, and that would give us the force exerted on the ball. If you're looking at momentum, obviously it's mass times velocity. This would be like, obviously if you were trying to work out how fast someone was going at a certain rotation or something like that, when these would come into play. And then finally, the third law: for every action, there is an equal opposite reaction. So, an example: in a long jump, the jumper pushes down on the board in order to go up. And if you look in football, the goalkeeper would push on with their left foot in order to dive right to save the penalty. And the same as kinematics, there's also angular kinetics. So angular kinetics is measured with torque. So torque is a rotation. Rotation must be initiated by a torque, and it results from a force acting at a distance from the axis of rotation. So the equation for this is torque equals force times distance, and is measured in newtons. So if I had a force of 6 and a distance of, say, 9 meters, so I times it together, and that would give us 54 Newton meters of torque. And that's how you work out angular kinetics. So if you look at force couples and momentum, if the same force is applied in both directions, the net force is 0. So if you had two American footballers running together to make a tackle, and they were going at the same speed, the force would be 0, and they would not move. They would just hit each other, and they would stay in the same place. The larger the couple, the greater the angular acceleration, therefore the speed would also be greater. If we look at this in relation to momentum, so if we looked at a gymnast, obviously the momentum can be travelled from one object in the body to another. So if you look at a gymnast, the gymnast starts this, obviously if it's going to do a spin or a flip, by pulling her arms to lessen her momentum of inertia. By the conversion of the momentum, the angular speed then will increase as she swings her arms up to produce this spin. Then to come out of the spin, obviously she has to extend her arms and increase her angular momentum and decrease her angular velocity, and then she'll bring herself back down to the ground. It's the same with runners. Obviously they use their arms to propel themselves further, and in turn obviously that makes them go quicker over time. Thank you for listening, and here are my references.